start with?
Let's start at number 45.
Okay, so have you gone all the way through hyperbolas or just through ellipses?
We've gone through all of them. I'm just kind of having a little hard time understanding each of them.
Okay. Do they give you the general equations or do they expect you to memorize
Yeah.
them?
Yeah. They give it. Well, we're not allowed a note card on the test.
Uh-huh.
So we have to pretty much memorize each of the equations.
Okay. So the general equation for an ellipse, for a horizontal ellipse,
Hmm.
is this. And if it's a horizontal ellipse, the a is under the x term. If it's a vertical ellipse, the a is under the y term and the b is under the x term. And the one thing you know is that a is always bigger than b for ellipses, not for hyperbolas, but for ellipses.
Okay.
Okay? So
Okay.
first of all, let's determine if this is the right general formula. In other words, if I draw a general picture, my center is right there
Hmm.
at 2 comma minus 2. And if my focus is at 4 comma minus 2, that means my focus is over here and I got another one there. What kind of an ellipse do I have? Horizontal or vertical?
Is it going to be horizontal?
Yeah, in other words, the fact that my foci and my vertex is going to be there and there, so it's got to be horizontal
Yeah.
because the center, the foci, and the vertexes all lie on the same line.
Yeah.
Okay, so if they were all lined up vertically, then I would know it was a vertical ellipse. Since they're all lined up
Yeah.
horizontally, I know it's a horizontal ellipse. So
Okay.
the vertex they're telling us is at 7 comma minus 2, and the foci they're telling me is at 4 comma minus 2. So we have
Okay.
our center, we have our foci, we have our vertex, which is a measurement of A. So from the
Hmm.
picture I've drawn, what is A?
Um.
A being the distance from the center to the vertex.
Would that be that would be 5, right?
Uh-huh. How about B? We don't
B would
know B
be,
yet. They haven't
or
given
yeah.
us B. So we have to calculate B. What
Okay.
they did give us was C. What is C?
Isn't C the focus?
Right, but it's the measurement from the center to the focus. How far
Okay.
is that?
That is 2.
Okay. And what is the equation that relates A, B, and C?
Isn't it C squared equals A squared plus B squared?
A squared minus B squared.
Okay.
Okay. In other words, it's not quite the Pythagorean theorem. It's close. For a hyperbola, it's A squared plus B squared. So the hyperbola is exactly the Pythagorean theorem. This is not quite, and the way to memorize what this is if A has to be greater than B, then you know that subtraction is going on. Because
Yeah.
if you get A and B's mixed up, you're going to be taking the square root of a negative number. So if you ever find yourself taking the square root of a negative number, you got your A and B backwards.
Okay.
Okay, so in our case, C is what?
C is it would be
Square root of A squared minus 2
um 2 squared, yeah.
square,
Or yeah, 2 squared 4.
square root of 21.
Okay.
So, hold on. I'm all screwed up here. Just a second.
It wasn't 4 the value of
Yeah,
C?
yeah, I forgot that usually I'm always solving for C.
Okay.
In this case, we're actually solving for B because we need to know what to write in there for a number.
Yeah.
Okay, so
So,
C
well, B,
was 2, so 2 equals the square root, we know A, minus B squared. Okay, now I can easily solve for B. I square both sides. So I get 4 equals 25 minus b squared. Take the b squared on the other side, equals 21. Wow, that's scary. I think my math is correct there.
yeah.
So b squared is what? Actually, I didn't even need b. Since the equation, that's what they want, right? Is what's the equation of this ellipse?
Yeah, well, they also want us to find, they also want to do a, like, to graph it too.
Okay, well, we graphed it.
Oh, yeah, yeah. So, that was it.
So we need to generally
We plug it in.
the equation. Let's plug it in. I'm going to write it right here in red. Our final
Okay.
equation. What is it?
Okay, well, so the origin, the origin is H,
The
or
center,
at HK.
not the origin, the center.
Yeah, that's the center.
Okay.
The center is,
the origin actually refers to the point 0, 0, always.
yeah.
So it's not.
Yeah, so the,
Okay, go ahead. Go ahead. Give it to me.
so the x value of the center would be 2, and that's also H.
Okay.
And then the y value is the value of, over, that would be 25.
Okay. And then it's plus y.
Plus y plus 2.
Okay. Squared. And b squared, which we solved for, was 21.
Yeah.
B was the square root of 21. We didn't actually need to solve for b, but we needed to solve for b squared. Okay.
Mm-hmm.
So there's the equation of this ellipse.
Okay. Okay, yeah.
And that was all they wanted, right? I'm not missing any print here.
No, that's the only thing they wanted to graph it by hand and just find the equation.
Okay.
Okay.
What next would you like to do?
Want to work on let's work on 47.
Your choice. You tell me what you want to work on.
Yeah, let's work on 47.
Okay. So 47, if we try to, the best way to draw or the best way to start these is to go ahead and try to graph them, because if nothing else, that tells you its orientation.
Yeah.
Okay. Well, if the vertices are at 4, 3, there's one vertice at 4, 3, and another vertice is at 4, 9, kind of an ellipse are we dealing with here?
Is it going to be a vertical?
Yeah, because if you draw a line between your vertices, that's your major transverse, that's your major axis. Okay.
Yeah.
So I can basically draw that ellipse now.
Okay.
Where's the center?
Well, would that? Well, we don't know it yet, but
Yeah, we do.
or it would, or I get well, it would be it'd be at 4, comma.
It's halfway
6?
in between, yeah, halfway in between 9 and 3.
It would be 6.
Okay, and then we also know the foci. They give us those, 4, 8. And that's all we're going to need to come up with the equation. Since it's a vertical ellipse, what's the general format?
Isn't it x minus h squared over, would it be b squared?
Yes. In other words, when you have a vertical ellipse, then A, the distance from the center to the vertice, is measured along the y-axis, right? It's measured
Yeah.
vertically. It's not measured horizontally. So
Yeah.
the A goes with the variable of the axis where it's measured.
Yeah.
Unlike hyperbolas. Hyperbolas don't work like this. They're actually quite different, even though the equations look very similar, but the A and the B are related in a completely different way. Okay?
Okay.
So
Okay.
what do we know? We know, well, let's try to figure out A, B. We really only just need A and B. We don't need C. But again,
Yeah.
they gave us C, so we need to solve for B probably.
Yeah.
First of all, and let's do our center. Where's our center?
For
Well, I
for
meant what's H and K? That's what I meant.
oh well h would be 4 and k would be 6.
Okay. What's A?
Wouldn't a would be 3.
What's C?
C, that would be, wouldn't that be 2?
That's the only information they gave us, was H, K, A, and C.
Yeah.
So again, we have to calculate B. And let's see, starting from C squared equals A squared minus B squared. That means B squared equals A squared minus C squared. And B squared is all we really need, not B.
Yeah.
So B squared is what?
Uh, well, b squared would be 9 minus 4, which would, and then b squared would be 5.
Okay, now we have enough to write the equation. What's the
Yeah.
entire equation going to be?
It would be x minus 4 squared over 5 squared, or 25.
Just 5. Be careful here. That's one of the problems.
Oh, yeah.
If you only solve for b squared, you have to be very careful, because notice that we got an A, we got a b squared, and we got a c. So let's be careful when we put in a squared also.
Okay.
What's the rest of it?
It's going to be y minus 6 over 3, or no, over 9.
There you go. So it's actually almost safer to solve for b rather than b squared.
Yeah.
In other words, if we solve for b, that's the square root of a squared minus c squared. B ends up being the square root of 5. And now we can plug that in for b, take away that square, and now there's much less chance of making a mistake.
Yeah.
It really is asking to make a mistake when you only solve for b squared.
Yeah.
Even though it saves a step. In other words, solving for b squared is solving for b is one more step than solving for b squared. But if you solve for b squared, you really risk making a mistake when you put it back into the formula.
Yeah.
Okay? And notice that a squared is bigger than b squared, as it must be always for an ellipse. Why? Because remember, a is always being measured on the major axis. Well, the axis is vertical. So whether you have a horizontal ellipse where a is this distance, or you have a vertical ellipse where a is that distance, it's always going to be bigger than b.
Yeah.
Okay. What else?
Actually, well, let's work on 49.
Okay.
We'll just kind of do all the odds.
Yeah, no, that's That's fine. Hold on.
Yeah.
Let me. Yeah, we're only gonna have 10 more minutes, so I don't know that we're.
Okay, yeah, maybe we can fit like maybe one more in there.
Yeah,
Or if,
we'll get this one done for sure. Um,
yeah.
so from this information, we can figure out whether it's vertical or horizontal. Just
Yeah.
from the foci, because you know the foci are in line with the major axis.
Yeah.
So based on the foci, if I go ahead and draw these 2 points, there's one of them, minus 1, 1, there's the other one. Is this a horizontal or a vertical ellipse?
It's going to be horizontal.
Yeah, we can almost draw it. The center is going to be right there. We're going to have
Yeah.
vertices are going to be approximately there and there. Remember, there's always 7 key points to any ellipse.
Yeah.
Okay. So starting with the general, what's the general equation for a horizontal?
It's going to be x minus h squared over a squared. And then y minus k over
I know
b
you know
squared.
the rest of it. Once you get that first left side of it, you got it all. And then
Yeah.
again, we need to know c squared equals what?
C squared equals
The general?
that would be oh no, oh sorry, c squared equals a squared minus b squared.
Okay. Because again,
Yeah.
they've given us the focus. So
Yeah.
we know c.
Yeah.
Okay. And the length of the major axis is 8. What does that tell? Well, first of all, we'll start with H and K and then A, B, and C. That's the way you want to do every one of these.
Okay.
Only they give you, this is what they've given us basically. What's H?
H is going to be um that will be
Excuse me, I got confused for a moment. Well, we know where the center is. What is this?
is it going will it be at 3?
It's halfway.
Oh
It's in. It's actually in between the 2 foci. That's the best way to figure it. Well, how much
oh
distance
yeah
is between the foci? 6. So it's
oh yeah
3
6.
to the right or to the left of this. So what does this
Oh
have to be?
the center would have to be 2.
2 comma 1.
Yeah.
Okay. And as long as we're here, I guess I'm not sure we need this. Yeah, we kind of need it. What's the XY coordinate of that vertex? If the
Um
length of the major axis is 8,
um
what's A?
A is going to be won't it be 4?
Yeah. In other words, we've got H is 2, K is 1, A is always half the length of the major axis, so A is
Yeah.
4, C is what?
C is going to be isn't that the distance from the center to the foci or for
Yeah,
the
to,
foci?
yes. So what's,
Okay, so that's going to be 3.
okay. And then we know that B is the square root of A squared minus C squared.
So that would be 16 minus 19 or 16 minus 9.
So B is the square root of 7.
Yeah.
Now I think we have everything we need for our formula. What is it?
It's going to be x minus 2 squared over 4.
Not 4.
Or no, 16.
Okay.
Plus y minus 2.
Minus 1.
Or no, y minus 1 squared over 7 equals 1.
There you go. There's the equation and the graph. And notice that it's always easier to start the graph first. Because when you start, well, I suppose that you'd eventually know whether you were dealing with horizontal or vertical after you did a number of these. But if you start your graph and start labeling some points, it becomes crystal clear whether it's horizontal or vertical.
Yeah.
Okay. Let's try to do more.
Okay.
Odds. Should we do 51?
Yeah, let's do 51.
Center, let me do it in black. Center is at 1, 2.
Yeah.
We have focus at 4, 2. What kind of ellipse is this?
It's going to be horizontal.
Okay, so that's one focus. So I know there's another focus over here, and there's a vertex there somewhere, and there, and I'm not sure which side of the x-axis it is, but there's my 7 points.
Okay.
Okay.
Okay, so I
H and K are what?
H is 1 and then K is 2.
Okay. A, let's see, we know the focus, and it contains the point 1, 3. So they're not giving us much here. Contains the point 1, 3. So our general equation is x minus, let's fill in as much as we know.
Okay.
Let me think for a second. Let's see, they gave us the focus, so they gave us C. How much is C?
C would be, it would be 3.
Okay. And C is equal to the square root of A squared minus B squared, right?
Yeah.
Okay. Now, if I take this point 1, 3 and plug it into as much of the equation as I know, I will come up with another equation with A and B squared in it.
Okay.
Now I'm going to have 2 equations and 2 unknowns, and I'm going to have to solve that system of equations for A and B.
Okay.
And that's not going to be that easy. We're not going to have time to do it tonight. But essentially, here, let me get you started at least. The point that it contains is 1, 3.
Okay.
So I'm going to plug that into there. 1, oh, that's going to actually help quite a bit. 1, 3 makes this term go away. So you end up with 3 minus 2 squared, so 1 over b squared equals 1. You see how I got that? By plugging in the point 1, 3 for x and y?
Yeah, yeah.
Well, that's good. That means b is 1.
Yeah. Yeah, because 1 over 1 is 1.
Well, I know c and I know b, so...
And then we can solve the rest to find a.
A has to be the square root of c squared plus b squared, just manipulating the original.
And yeah, so it would be 9, or it would be
Square root
square root of 9.
plus 1.
Yeah, plus 1.
Okay.
Okay, yeah, it would be
In
square
other
root of
words,
10.
C is equal to this, but A is equal to this.
Okay.
Right? Because C squared equals A squared minus B squared, then A squared equals C squared plus B squared.
Yeah.
So A is the square root of the C squared plus B squared. So A
Okay.
is square root of 10, and now we have everything you need. Those 5 numbers are all you need to come up with the equation.
Okay.
As far as graphing it goes, start with your center, add A to get that vertex, add B to get the minor vertexes. You know how to
Okay.
do the rest?
Yeah, yeah, I know how to do the rest. It was just, yeah, it's kind of
I'm not positive that that bottom is above the x-axis because I haven't calculated. Oh no, B is 1. And the center was at 1 comma 2. So I do know. What's the coordinate on that minor vertex right there?
it'll be it'll be 1 comma 0
1
or
comma
1 oh.
1.
Okay, 1 comma 1.
Because B is 1.
Okay.
In other words, it's going to be 1 below the center.
Oh, okay.
This vertex would be 1 above the center. What's this? The major vertex. And then I'll let you go.
Yeah.
Because
Yeah.
the way you write these is a little peculiar. How do I write this? A is square root of 10.
Yeah. It's going to be
1 plus
1.
root 10, comma 2.
Okay.
That's how you write it. You don't turn it into a decimal.
Okay.
They want the exact point, and the exact point
exact
you have to define it with radicals. Over here, it's 1 minus root 10, comma 2. That's the vertex. In other words, you always start from the center, and you add A or subtract A to get your 2 vertices.
Okay.
And then this vertex up here is 2, it's 1. The x-coordinate doesn't change. And the y-coordinate is 2 plus 1, or 3.
Okay.
So that one is 1 comma 3. And that's why that point was on the curve. Notice.
Yeah.
That point that they told us was on the curve is actually one of the minor vertexes. And that's why it solves so easily. Had they given us a point over here, then B would not have solved so easily, and we would have ended up with 2 equations and 2 unknowns. And that's one of the harder ellipse problems. I haven't seen one where you actually had to solve a system of equations, including this one. Because they put the point at the vertex, it made it really easy to solve directly for B without having to solve a system of equations.
Yeah.
Peyton, I hate to run, but I'm now 4 minutes late for my next appointment.
Oh, yeah, sorry. Yeah, sorry about that.
That's okay, not your fault. I was late for this one. So I'll talk to you next time.
Okay, yeah, thank you.